Hello, everyone. Welcome to our webinar, our weekly webinar. My name is Javier Ortiz. I'm your mentor throughout this program. Just as a reminder, you can schedule a one-on-one call with me every week. Go to mccannelly.com/Javier Mortiz. That's JAVIER MORTIZ. You have the link on Slack and you can schedule meeting with me. I just updated my available slots, so you should have more available slots to choose from. All right, with that being said, we are currently working on project number 3, which is data warehouses, which is due in about 2 weeks. So today I'm going to walk you through this project. And this project is all about AWS and building an ETL pipeline incorporating AWS, Amazon Web Services. So here we are on the project description. All right, so once again, we are a startup, Sparkify, and we are working with this song database and user base that you should be really familiar with now. The thing now is, even though we're working with JSON files, once again, these JSON files now reside in an S3, which is a sort of it's a service from AWS, which is basically like a machine with a lots of storing capacity, and so it's pretty common to use it as a way of storing any data that you have. So we're going to build an ETL pipeline. Basically, what we want to do, we want to extract information from this S3, and we want to have it in staging tables, transform it, and then load it into our tables, which is going to have a star schema. All right? And that's basically what we're going to do. So just once again, so that we're able to query this schema and perform analytics on it. Okay. So the data sets, the song data resides in this S3, and the log data in this S3, and they provide you with the path for both of those. And once you the sort of files you're going to extract from the song data in the S3 is this sort of files, right? These JSON files, and each file contains these information regarding a song. So it's num songs, artist ID, artist latitude, longitude, location, artist name, song ID, title, duration, and year. And from the log data set, each JSON file looks something like this. So it's this information regarding the users, artist, auth, first name, gender, and essential last name, etc. All right. So why is this important? Okay. So since as you learned during the lessons, we're going to extract this information and we want to have it in a staging tables, right? And in that way, we'll have all our files in just one table regarding the song data, and all our files regarding the user in another table. And we want to have columns that match these different information, these different data, and we want to store them accordingly to the way data is organized already. Since we know all of these files follow this organization, this structure, our staging table will follow this as well, and the other staging table will follow this structure for the columns. Awesome. Okay, so the project instructions. So they provide you with the star schema that they want to use. And we have a fact table someplace, which is basically data regarding the user activity along with some songs. I'm really sorry about that noise. It's going to be gone in a couple of seconds. And we have some dimension tables which provide users information, songs information, artist information, and time information. All right. Now, once again, this sort of a schema is really, really important. And the way you justify this, because you need to justify it in your readme file. As you can see here, we have the user activity, but user activity is strongly related to song data. For example, we have the song ID and the artist ID that this user is listening to. And imagine if we were to hold all the information regarding the user, and I mean regarding the song, yes, and even the user. But let's focus on the song and artist. If we were to include all the information regarding the artist and song here in the same table, since many users can listen to the same artist, we will have this name, location, latitude, and longitude repeated many times. So every time a distinct user is listening to the same artist, we will repeat all of this information. So I mean that would be like this duplicated data, storage capacity wasted. So that's the main reason why we use this sort of a star schema, and this has basically everything we need, like to query, to perform analytics. And if we ever need to get some of these results, we can easily get these sort of data by joining these tables, which would be an easy join. All right, with that being said, we have 4 files: create table.py with created tables, the ETL, which inserts the data into the tables, SQL queries, you have the SQL statements for creating the tables and dropping the tables and copying everything. So basically these two borrow the queries from here and the README file. And right here are the project steps. So let's start with creating the table schemas, right? So the design of schemas for the fact and dimension table is already done for you right here. And so let's start by writing the create statements. That will be in the SQL queries. So let me open the project workspace right here. Awesome. Okay, so the first thing we're going to do, we're going to open the SQL queries. And here, what this does basically, all your authentication data, like the database, password, everything you need, that it's in this file, and basically you extract it from this file into this config. All right, so we start by writing the create tables. So you need to start with 2 staging tables. As I explained, you have all the files in JSON files, so you want to extract all of those JSON files into just one table to make it easier to transform and load to your final table. So we have a staging events table. This is for the information regarding the user. And as you can see, all of these columns are basically taken from, oh no, I wanted a new tab, are basically taken from here. All right, I'm following this structure in order to extract all of these files into my staging table, right? So I'm following this, just making sure that the data type is correct. We're not doing anything fancy, and we're not doing any restrictions, not null or primary keys. I mean, we just want a bucket, right? We do the same for the songs data, and this one will follow this structure: num songs, artist ID, artist latitude, right? Okay, and after we have that, then we're going to write the create queries for our schema, which we have, right? We don't have it here. Where is it? I lost it. All right, here. Okay. So we're going to follow this, and you have the columns already provided to you. So in this case, you do need to define which is going to be the primary key, which ones need to be not null. And remember that the ones that need to be not null are the ones that are related to user activity, that we wouldn't be able to define which user are we referring to if that would be null, right? And one quick thing is that Here for AWS, you cannot use serial, which we use in the previous project, but you can use identity, which is basically the same. So identity, what it does is it starts with a 0 and is going to be adding 1 to each instance of that, to each new row in that column. So my first song play ID will be 0, my next one will be 1, then 2, 3, 4, 5, etc. Once again, make sure you have the proper data types here. You do the same for each table. You define which one is the not null primary key, and you define the different data types. We do the same for the other dimension tables: song table create, artist table create, and time table create. All right, so that's pretty straightforward. And once again, these columns, you got them from this schema, right? Cool. So let's move on. All right. Now complete the logic and create tables to connect to the database and create these tables. Before you do that, I suggest you write your drop statements. Let me open the create tables. As you can see, create tables, what it does, it reads the DWH file. So you need to get that set up first before you run this file. And then it runs the drop tables and then the create tables, which it borrows from the SQL queries, which is this one. So let's write the drop tables first, which is pretty straightforward. Don't forget the if exists. As you saw here, this main runs the drop tables first. So if it is the first time that you're running this and you didn't write the if exists, it would crash. It will crash. So make sure you write the if exists for the staging tables and for the star schema tables. All right. Once we have that, and that is step 2 and 3. So we can, and even 4. So what I want you to do next is I want you to fill the information that we need here in the DWH. And let's open that file to see what information you need. So basically, we're taking this info to connect to our AWS Redshift cluster and use our IAM role. So we need a host, a database name, user, password, port. We need the IAM role, and these file paths are already provided, right? So we just need to fill out the first 2. Okay, so what we're going to do, we're going to go to AWS, and first we're going to create an IAM role. And we're just going to write IAM, which stands for Identity and Access Management. We'll click here where it says roles, and right here where it says create role. All right, so we want to create a Redshift one, and because that's the service that will use this role. So click Redshift, customizable, and then here, down here, next permissions. All right, create policies. So we want to make it able to read S3 because those are the buckets that we're using. So just type here S3, make sure you check on the Amazon S3 read only access, and let's click on next. All right, then next review. You can skip this one and add a name to the role name. I mean, it can be any name that makes sense to you. I don't know, like Redshift 1, or I don't know. You choose a name for it, and then you create the role. I'm not going to create it because I already have like some roles created, and I haven't erased them. But let me show them to you. So if I go here to roles, these are the roles that I created. The one that I'm using for this project is my Redshift role 1, so that's a name you can use. And once it's created, it will show here in this directory, and you can click on it. And here it says that role ARN. So you can copy this. You can click on this and it will copy it. And this is the one that you need here for the IAM role, right? So you can copy and paste it right here, and that is done. All right, let's continue. Now, what we're going to do, we're going to launch a Redshift cluster. So once again, right here, we can just write Redshift. And here where it says quick launch cluster. Here, I mean, you can use 2, but I'm going to go with 4 because that's what the teacher recommended. So I'm just going to go with 4. And this is the node type. And here you name the cluster, you name the database port. All of this are the default. So I just leave it like that. Master username, I also did use the default. The user password is up to you. So come up with a password that you won't forget. And here you can link it to the role that you created beforehand. In my case, it was my Redshift role. And that's pretty much it. You launch the cluster then. It will take a couple of minutes to create it. And once it is done, it will show here and it will say cluster status available. So it's really pretty straightforward. And we need some data regarding that. So if you click here, it will show the cluster name, which you need. Oh, you don't need here. You need the database name, user, password, and port. Let's start with that. So the database name is right here. My case is dev. The user is AWS user. The port is 5439. The password, you should have memorized it when you created it. There must be another way of checking the password, but I really don't know it because I just memorized it when I created it. And where it says host, what you want to do, you want to copy these language as server, all right? It copies the whole thing, but you can just copy and erase whatever you don't need. So you need basically after server and up to the semicolon. Don't include the semicolon. So you copy and paste this over here, and it will. That's the endpoint of your Redshift cluster. Cool. Now we have this field. This is like the trickiest part. Like, I mean, it's not even tricky, but I had a really hard time like understanding what host it was referring to, but I mean, it's pretty straightforward. It's the endpoint. Let's continue. All right. So we already added this data over here, and now you can run create tables. So what we want to do is we want to open a terminal, and right here just type Python and create tables.py. I'm not going to run it because my project is already set up, working nicely, and I don't want to mess it up. Right. So once you do this, it should run. And the way you check that it runs is right here in the Redshift dashboard. You can go where it says query editor. It will connect to database. It might ask you for the password. And right here, we already created our tables, the staging tables and the song place tables and the users. So if you want to check each table is fine. I just checked that one. I want to check the song place. I'm going to select everything from song place, and I'm going to limit to 10 so that it doesn't take long to run. All right, as you can see right here, these already populated. Yours, when it is the first time you run create tables, they won't be populated because you haven't populated them. But they should show the headers because you already created the tables. And that's really what you want to check at this stage, that these columns match whatever you wrote in your SQL queries, in the create queries. And you can check all of your tables just to make sure that they are according to what you wanted. All right, so that's how you check that you created the tables. And that's the first part. That's the creating the tables part of it. And now let's move on to the build the ETL pipeline. So it says implement the logic in ETL.py, load data from S3 to staging tables on Redshift, implement the logic, load data from staging tables to analytic tables from Redshift. So basically what we need to do, we need to extract the files from the original bucket into our staging tables. And after we have that, we're going to load the data from our staging tables into our star schema, right? And so let's do it. So I'm going to open the ETL pipe so that you can see it. The first thing it does, it takes all our configuration data that you already have set up, so that's done. And then it sets load staging tables and insert tables. So these two methods, they come from the SQL queries. So we need to fill them out here in the SQL queries. And you can see them right here, right? And the way we load data from the S3 into this is we're going to copy staging events, right? And staging events is this table right here, staging events, and the other one is staging songs. All right, so we're going to copy into them, copy staging events and copy staging songs. All right, and from, and then we have like a string format, IAM role string format, and JSON string format. And here, after the format, the from, it says it takes it from the config file, which is this one. And as you can see, if I access the S3, here I have the file path for the log data and the song data and the log JSON path. So here I want to copy from the song data path, which is this one. And this is how you access it. And then the IAM role is going to come from this. So I just access it this way. And JSON, I'm going to, for the staging events, I'm going to use the log JSON path, which is this one. But for the staging songs, I'm going to go with auto. I mean, those are the recommendations according to the teacher and on the lesson. So this is pretty straightforward, but this part can be tricky. So just make sure that to understand where this data is coming from, which is this file. And the way you access that file is like with indexing, the IAM role, and this, then indexing the ARN. And the same for the file paths. Since they are inside variables, you use the variables. All right. So that's the first part. And once we run the ETL, we are going to populate our staging tables. And oh no, yes. All right. Sorry for a second. I thought I wasn't recording, and I was like super sad, but I am recording, so everything is all right. Okay. Okay, let's continue. So once we have our data in our staging tables, we want to take that data from the staging tables, transform it, and load it into our star schema. So you're going to write your insert statements for each table in your star schema. And the insert is really easy. Insert into the name of the table, then all of the columns that you want to populate. And then as you did in the previous project, you're going to select where do you want to get this data from. And we're getting this data basically from the staging songs. That's the staging table, or the staging events, right? So it's one of those two. and basically you write SQL queries to access those tables, right? So for example, here I want the start time and the user ID and the level from the staging events, and here is the table, and I created another temporary table right here to get the timestamp, and I joined it to the staging songs in order to get the other information such as song ID, some artist ID, and I think that's pretty much it. And the way I joined it is just whatever they have in common, which is events.song equals song's title, and events.artist equals song's artist name, and length and duration. So whatever they have in common, join them through that commonality. All right. We do the same for each table. You insert into, you specify the columns, then you select the columns from the staging tables, and in some situations you will need to use the word page equals next song. And we do the same for the song table insert, artist table insert, and time table insert. This one is like the trickiest because you need to extract hour from start time, extract day, but you already know how to do this. And that's pretty much it, right? So that's how you populate your tables. So let's go back here to instructions. Once we implemented the logic in the ETL pipelines, we need to test it by running the ETL after running the create tables. So since you already ran the create tables, you can just run the ETL pipeline, which is etl.py. You run it, it should run if everything is working correctly right here. And now it's time to check it. And the way you check it is you can run some analytic queries on the Redshift database. I mean, you can do that, or you can just start. For example, right here, I know for sure that it worked because my tables are populated, and they are populated as I described them, and my start times work, and I have all the data as I envision it to be in my tables. So here's where you test that your tables were populated. And if that is the case, congratulations, you did it. You finished the project. You just have one more step. Okay, and that step is document the process, right? So in the README file, you're going to discuss the purpose of this database and state and justify the schema, and you can provide queries if you want to. So let me show you really quickly. Oh, and yeah, let me show you really quickly how mine looks. So the purpose of the database. So basically, you want to store the relationship between user and the song that the user is listening, and that we can do some analysis that we couldn't do before because we had all our data in individual files, which were not suited to query easily. And justifying your database, once again, is the thing about duplicated information, that you don't need to duplicate data. For example, if the users are listening to the same artist, you don't need to hold all of that artist information into the same table that holds the user listening information. You can have it in a different table in order to avoid duplicated data. And just make sure you just like give a description of each table that you created. For example, for staging events, here, where did I get my data for this one? Oh, I got it from from the original log files were in S3, and I use this one to create the fact tables. I mean, from this, I would extract my data to my fact table. So you can see something like, I extracted all the files, into one table for an easy extraction into my final fact table or something along those lines. And that's what you need to do for each table, basically. Just, oh, these are the columns that I decided to have. This is where I got my data from, and this is the purpose of this table. And yeah, that's basically the README file. And that's it. You have a submit project right here. So you can hold all your data right here. I suggest you don't need to include your password. It's up to you. But yeah, you don't need to include it if you don't want to. And submit project. The reviewer is not going to run your entire project. He or she is going to just check the logic of your implementation. And so it says here at the final step, delete your Redshift cluster when you're done. So if you go here to Redshift dashboard under clusters, you can just select your cluster, and here in search cluster you can delete it. And a snapshot name, I'm just going to call it Redshift cluster 1 delete. And the maintenance, no. So I think that's it for my cluster. And you can reboot it, but I mean it's deleted for now. Cool. And that's it. That's the whole project right there. So hopefully you have enjoyed this project walkthrough. You have about 2 weeks for this project. The project is not that difficult, but if you have some lessons that you want to catch up with, now is the time to do that. And remember, you don't need to wait until the final day of the due date the final due date to submit your project. As soon as you have a working project, submit it and let the reviewer do his or her work. And yes, and as soon as you have completed your project, keep going. Once again, remember you can schedule one-on-one call meetings with me through Calendly. And each week on Tuesday, I provide a weekly roundup where you can find the link for our webinar and to schedule the meetings with me. If you need any assistance whatsoever, don't hesitate to ask for help through a Study Hub, through our Slack channel. DM me, send me a DM, and yes, I'm here to help you guys. So I'm really happy. I've been watching your progress, and I'm really happy to see that many of you already completed projects 1 and 2 and are working towards completing project number 3. So congratulations and see you soon.